All right, I thought I would just do a couple of problems to give you a sense of how they work. Um, I'm going to do, these are from the back of chapter 8 in the text. I'm going to do problems 8 and 13. And so this is problem 8 here about Heck's berries, and they have a cost of production, total cost, and you're given a marginal cost, and we'll work through this. So the total cost, you're told, is q cubed minus 12q squared plus 100q plus 1000. And hopefully that'll focus in just a second here. Seems like it focuses better with the hand there. All right. And you're also told that the marginal cost is, and you can figure out marginal cost just by taking the derivative with respect to q, but you're told that the marginal cost then is 3q squared minus 12q plus 100. Part A asks you to find the to find the total fixed cost. So the total fixed cost, if we go back up to the total cost curve, you can see that the first three items or the first three elements there all have Q's in them. So they're variable. Their values change as the level of output changes. But this is fixed. And so the 1000 there is in fact the fixed cost. Part B asks, what is his short run average variable cost? So average variable cost is going to be total variable cost divided by output. The total variable cost is just going to be the variable elements of total cost. So that's q cubed minus 12q squared plus 100q. The average variable cost then is going to be this divided by q. That's q squared minus 12q plus 100. That's the average variable cost. Part C asks, if berries sell for $60 per crate, how many should he produce? So if price equals 60, Q should be what? Should equal what? So the first question we really want to ask when we're doing a problem like this is $60 above minimum average variable cost? We know that if it's below average variable cost, the firm will want to produce zero, will want to shut down. If it's above average variable cost, then we can figure out what the quantity is. So let's do this first. Let's figure out the price at which average variable cost reaches its minimum. And what we know is that average variable cost reaches its minimum when average variable cost is equal to marginal cost. Go back and look at the pictures that we did, and we'll see that marginal cost always hits average variable cost at its minimum. Let's set the two together and figure out what price that would be at. So we'll set marginal cost, 3q squared minus 12q plus 100. We'll set that equal to average variable cost, q squared minus 12q plus 100. And so that's going to give us 2q squared. Is that right? Minus 12q. Oh, I see the problem. That should be 24q. 2 times 12 is 24. So the marginal cost is 24q. Sorry about that. And I didn't think these two things cancel each other, and they don't. And so this is going to be minus 12q equals 0. So we can factor that Q is 2 minus, oops, Q equals 2. Sorry about that. Just factoring out the 2Q, we get 2Q times Q minus 6 equals 0. So Q equals 0 or Q equals 6. We're not very interested in Q of 0. What this says is that marginal cost equals average variable cost when the quantity is equal to 6. When the quantity is equal to 0, they're both 0. And so that's not very interesting. So when the quantity is 6, what is the level of either marginal cost or average variable cost? They're going to be the same. Looks to me like the average variable cost is a little bit easier to work with. So we'll say average variable cost equals 6 squared minus 12 times 6 plus 100 when Q equals 6. So that's 36 minus 72 plus 100. So that's 136 minus 72 is going to be $64. So what have we figured out? We've figured out that this is the minimum value of average variable cost. If the price is set at $60, that's below minimum average variable cost, and the firm is going to want to shut down. And so at this price, at a price of $60, the firm should produce nothing. It should shut down. Part D asks, if the price of berries is $79, how many berries should they produce? So if the price equals 79, then we know that's above minimum average variable cost. The firm will in fact want to produce. We'll set marginal cost equal to marginal revenue. The marginal revenue is $79. So we'll set 79 equal to 3Q squared minus 24Q plus 100. So we'll get 0 equals 3Q squared minus 24Q plus 21. We can factor this if we're clever, or we can use a quadratic formula. Either way, to solve for Q, we get Q is equal to 1 or Q equals 7. Those are the two roots of this equation. The firm is always going to maximize profit at the larger quantity. So we generally will ignore the smaller quantity and say, this is our solution. The firm should produce 7 units of output at a price of $79. All right. Problem 13. I also want to do problem 13 is here, and it's about almond growers and 2 sets of almond growers with different costs of production. One set of almond growers are in a rainy area, so their marginal cost is 0.02Q, and one is in a relatively dry area, which means it's more costly for them to grow almonds, and their costs are higher. Marginal cost is 0.04Q. And so there are several questions there, and we will work through those. So the first question is, the first question asks us to find the individual supply curve for each type of grower. So what we're told is that there are 500 growers. This is problem 13, part A. There are 500 growers with marginal cost equal to 0.02 Q. And there are 300 growers with marginal cost equal to 0.04 Q. And part A asks us then to find the supply curve for each type of grower. Well, we know that the marginal cost curve is the supply curve, but we need to rearrange it in order to get a proper statement of a supply curve. So what we can say is that for the 500 with good conditions, price is equal to 0.02 Q. That's an inverse supply curve. To find the supply curve, we need to solve for Q, and so we'll get Q equals 1 over 0.02 P, or Q equals 50 P. So Q equals 50 P is the supply curve for the 500 growers with good conditions. For the 300 with not so good conditions, the inverse supply is price is 0.04 Q. And so the supply curve is going to be 1 over 0.04 P, or Q is 25 P. So those are the supply curves for the individual growers. Part B asks us to add up the individual supply curves to find the market supply curve. Okay, so the market supply curve. So if you envision these curves, looking at the inverse supply curves, price is 0.02 Q, that has an intercept of 0. Price is 0.04 Q, that has an intercept of 0. And so there's a supply as long as price is above 0. So we don't have to worry about any sort of kink in the supply curve. All suppliers enter the market for any price above 0. All we need to do is to sum these horizontally. So that means we're going to add all the quantities together. So the market supply is going to be 500 of these, 500 times 50p, plus 300 of these, 300 times 25p. So we're summing quantities here. So that's going to be 25,000 p. Those are the growers with good conditions. That's their market supply. Plus 7,500 p is the market supply for the not so fortunate growers. And so the total market supply, the market supply curve for the entire market is 32,500 p. That's part B. Part C says, if the market demand for almonds is as given in the problem, what will be the equilibrium price and quantity? So the market demand as given in the problem is 105,000 minus 2,500 p. So to find the equilibrium price and quantity, we'll just set the market supply and market demand equal to one another. 32,500 p equals 105,000 minus 2,500 p. So that's going to be 105,000 equals 35,000 p, or p is equal to 105,000 divided by 35,000. That's 3. So that's the equilibrium price. The equilibrium market quantity is going to be 3 times 32,500. That's 97,500. Finally, part D asks, how many almonds will each type of almond grower produce at that price? So part D, at price equal to $3, the 500 growers have a market supply of 25,000 P, and so for them, they will grow 25,000 times 3, which is 75,000 crates of almonds. And for the 300, their market supply is 7,500 P. So 7,500 times 3 is 22,500. So that's how much each type of grower will produce. And part E says verify that the total production equals the equilibrium quantity. So if we sum those together, that's 97,500, which in fact is what we found before. So that's problem 13. Please let me know if you have any questions.